Okay, number 2, here we go. An object is projected horizontally at 8 meters per second from the top of a 122.5 meter cliff. Draw a sketch, label it with all the numbers provided, and solve the problem. Okay, so pause it, draw your sketch. I'm not going to draw the sketch this time. You guys saw how to draw it last video. Hopefully you got that. Now let's move on to B. What variables do you have? Distance, x distance. We do not have that because it doesn't say how far it landed. So that's a question mark because it does exist. Y distance. How tall was the cliff? 122.5 meter tall cliff. 122.5. I'm going to move a little bit. I don't want to say faster, but I'm going to skip over some things in this one. If you're looking for details, look at the last number 1. But this one I'm going to skip over a few things. X velocity. What was its speed out the gate? 8 meters per second. 8 meters per second. Y velocity. There is no Y velocity. That's going to be 0. That defaults to 0. X acceleration. In other words, your lateral acceleration, again, that's going to be 0. Defaults 0. And the Y acceleration is all the acceleration of Earth's gravity. As long as you're on Earth, that's going to be 9.8 meters per second squared because you square meters per second squared always means acceleration. Time. They don't give us a time, but it does exist, so I'm going to put a question mark. Next, we are going to solve for time. Hopefully we have the time. All right, so here we go. Let's look at the displacement they give us. They give us the y displacement, so that's what I'm going to start with. So my formula, displacement of y equals the initial velocity times time plus 1/2 acceleration of y times time squared. All right, I'm going to start plugging stuff in. Displacement of y. We have 122.5 as the displacement of y. We have that already. Equals initial y velocity, that defaults to 0, times time plus 1/2 times 9.8 is the y velocity times time squared. So this is gone. So now I have 122.5 equals 4.9 times time squared. Divide 4.9 out. Divided by 4.9. So number 4 is going to say time squared equals, and now I'm going to do 122.5 divided by 4.9, which is going to be 25, because I have the key and I don't have to do the calculator. Woohoo! And you can probably do this in your head, but just make the habit anyways. I need just t, so I'm going to square root this, because that gets rid of a square, which means I square root this, which means t equals 5. Easy money. So now we have our time. So now if we want to, we can come back up here and say, hey, it's not question mark anymore, it is 5. Right? Okay, how far from the base of the cliff will the object strike the ground? What does that mean? That sounds a lot like x distance, right? So our displacement of x equals, I'm going to write my formula, initial velocity times time plus 1/2 acceleration of x times time squared. Plug in what I know. They're asking for this, so obviously we don't have that. Equals initial velocity. Our initial velocity was 8 meters per second, so 8 times time. Hey, guess what? We have time now. 5 plus 1/2 acceleration of x is 0 times 5 squared. Well, you know all this side is going to be times 0 anyway, so I'm going to slash that. So now we have displacement of x equals 8 times 5. Wow, that's easy. So our displacement of x is 40. And since it's how far, it should be in meters. And this should have been in seconds. And that's it. So the last video we made was 7 minutes. This one is running to be about 5. You guys may have taken a little bit longer than me since it's the second problem, but that's okay. But notice that we shaved a lot of time off because you kind of know what you're doing. So at this point, it's a piece of cake. So I'm going to do another one. I'm going to do one more, and then I'm going to hand it off to you guys, and I'm probably not going to do any more, but we'll see. So let's look at number 3. A person kicks a rock off a cliff with a horizontal speed of 20 meters per second. It takes 7 seconds to hit the ground. Awesome. They give us a different one this time. Draw a sketch. Pause it and draw your sketch. I'm not going to do that. And let's rock and roll. What variables do you have? Okay, so I noticed that they don't give us any displacement. They don't say how tall the cliff was, and they don't say how far it landed from the cliff. In other words, the x. So this is going to be it exists but I don't know, and this is going to be it exists but I don't know. Okay, initial horizontal means x, right? Speed, or velocity we'll say, is 20. Okay, so initial horizontal velocity, 20 meters per second. Initial y velocity, that defaults to be 0, right? Initial x acceleration, in other words, your flat sideways acceleration defaults to 0. And then your y acceleration is always the acceleration of Earth's gravity, 9.8 meters per second squared. Cool. Well, awesome. Time. Oh yeah, they actually give us time, so this is 7 seconds. There we go. Calculate the height of the cliff. So when I hear height, hopefully you guys hear the same thing. I hear y. Right? So, here we go. The displacement of y equals initial velocity times time plus 1/2 acceleration of y times time squared. Monotony is knowledge in physics. So, displacement of y, we don't know what this is, equals, what's your initial y velocity? Well, that defaults to be 0, right? So 0 times 7 seconds, because our time, they give us it this time, plus 1/2, our y acceleration is gravity of Earth, 9.8, times 7 squared. So now we have our y displacement equals 4.9 times 49. So 7 times 7 is 49. 1/2 times 9.8 is 4.9. So our y displacement equals, you do the calculator, I look at the key, 240.1 meters. Bam. Cool. So that solves this one. And that gives us this, 240.1 meters. We have that. Calculate the final vertical velocity. The final vertical velocity. So that is going to be acceleration times time. So this one's a little bit different because you're using a kind of a different formula. Acceleration times time. So that's going to be 9.8 meters per second squared times 7 seconds, which equals 68.6 meters per second, because that's a velocity. Bam. Awesome. Not very hard. Same formula. Different parts of the same formula. Easy money. Ooh, I just got an email. That's not that exciting. Okay. Well, there you go. Use the knowledge that you have. From here on out, notice that they're not going to give you a list of variables. You make your own list. At least you have a question, but you make your own list. And then the next one, number 5, well, they do the same thing. Remember, some of them could be 2-part questions. And then once you get to number 7, they kind of take the training wheels all the way off. You have one question. It's probably a 2-part question if they give you the entire page. Also, make your section of what you have off to the side. Always off to the side. Very easy stuff. 10 minutes exactly. We'll roll it out 10 minutes. 2, 1,